Hey everybody, it's Michael. Welcome back to Let's Explore Unity. This is episode 11, and this episode we're going to look at getting references to objects. It's something that we've already done in this series so far. We went kind of a little bit ahead, and then I think I've been pulled back to talking about some of the fundamentals that I think a lot of people kind of gloss over when they're showing how to do stuff in Unity. So let's look. I've got just a little presentation slide over here. Let's see if it'll open up. There's two sort of modes in working with Unity. There's design time and there's runtime. So design time is when we're using the editor and the Unity scene view, and we can give our scripts access to various objects in Unity by making in a script a public access modifier and a class and naming it. And that'll appear in the Unity inspector. And that's a great way to allow somebody who maybe doesn't know how to program access to your stuff, say a level designer or something like that. But it's also a good way, a good kind of easy way of getting a handle to or a reference to an object if you know that there's only going to be that one and it's never going to change or anything like that. This can kind of easily get broken if you're not careful as you go along and you change things and stuff, and you'll find yourself dragging over and getting connected again. Still, it's a very useful way of doing things. And then at runtime, we have a number of different ways of getting a reference to an object so that we can manipulate it in code. We can use some built-in methods to find objects by their type, by their name, and by their tag. And we'll look at all of those ways of doing things here in just a little bit. Let me end this slideshow and pop over to Unity. And I've just got a pretty much a blank scene here. We've got a ground plane. There's a couple of these capsules with a collider on them, a mesh renderer, and a material that we can get access to if we want to mess with some of that stuff. And I have a couple of different scripts here. I have just a script that's hanging on this empty game object called references, and I have another script on this player which is called player. And we're going to take a quick look at some of the ways we can get access to something. So let's say that in our manager here we wanted our references to have access to a player object. Well, one thing that we could do, and you guys have already seen this probably a million times, but hopefully I'll be able to tell you something that maybe you didn't know or hadn't thought of so far. But let's look at this. So if we type in public, this is let's see, what did we say? Public keyword is an access modifier for types and type members. Public gives access to this variable that we're going to create to things outside of this class, including Unity. And Unity uses things that are tagged public to expose them if the script is hanging on an object, exposes it in the editor so that we can get access to it. So if we say public game object, and let's name it player, save that, and go back to Unity, and we look here at our script, as soon as it compiles, you'll see that we have a spot here for a game object that is called player. And if we drag over that player, there it goes. So now once we've got that done, we could in here do something like player.setActiveFalse, which is basically if we actually got an object over here, if it's not null, we're going to just turn it off. So let's see if that works. And it didn't work for some reason. Why didn't it work? Oh, because I didn't save the file probably. Let's go back and try that again. Yeah, there we go. So the player goes away. All right, that's very cool. But so there's an additional problem here with this, or a problem, something you should think about. Let's not call it a problem because it just depends how you want to do things. By making this public, anything that can get access to this class can also get access to this player and can change it. So while we might want our references class to be able to set the player object to inactive or change its material or do anything else to it, we might not want that to happen. So we've got a couple options here. If we made this private, only this class knows about it, unless we make some kind of accessor function so that we can get and set this object. But right now, private means that nobody else can mess with this. And that might be the way we want it to be. We might want it to be protected so we couldn't accidentally hurt it. Also note that if we leave this off, it's still considered private. Private is sort of the default state. But even with it marked private, we can still make this available within the Unity editor. And we can do that by setting what's called an attribute. If you look at the Unity documentation, there's a number of different attributes that we could use. And the one we're interested in here is called serialize field, which serialize means to, convert an object to data so that it can be written or whatever. But importantly, by serializing, it gives the Unity editor access to it so that it can make it available in the inspector. The way we serialize a field is simply by putting this behind it. Let's check out what happens when we do this. Actually, first, let's save this and then go back over to Unity and take a look. You'll notice that our reference to our player goes away, but if we come back over here and type a square bracket, serialize field, and save that again, we come back over here and we're going to find when it compiles, now we do actually still have access to that. So even though another class in our project can't get access to this, we can still access it in the inspector, and that may be a behavior that you want to have happen. Let me show you one more thing, by the way, which isn't related to this necessarily, but it is an important thing. We might want other classes to have access to something. So for instance, let's say that we had something like public player speed. Well, we need to give it a type, int player speed. We might want this to be available in the inspector so that it can be edited and do something. But what if we had another variable that we don't necessarily want to edit in the inspector, but that we do want other classes to be able to access for some reason, for whatever reason, it doesn't really matter. Well, we can do that. We can still declare a public integer, and let's call it, some value that we want other classes to have access to, but we don't really want you fiddling with in the inspector necessarily. There's another attribute that's useful for that, and that one is called hide in inspector, which, if I can get it to respond, yeah, there we go. And it's the same thing, just in brackets, hide in inspector. Well, let me save this. And let's go back over here and look at our script. You'll see now that we have player speed, which we might want access to, and then we have some value, which we say, okay, I don't necessarily want people to be able to change that in the inspector anyway. We can do hide in inspector, use that attribute, save it, come back over here. And notice that it's gone away. So other classes can now still access this, but we can't access it in the inspector. So that's the first bit. We're done with that. It took a little bit of time because we wanted to cover those extra items, and let me comment that out so it doesn't break. So now how else could we do this? Well, we can find objects by distinctive characteristics, and there's a few different ways to do that. So let's say that we had let's make this private game object player. I probably already had that and just deleted it. And then in start, let's say we want to get a reference to this player, but we're not going to want to get it through the inspector. We want to find it some other way. There's a couple ways to do that. Well, we can say find object of type if we know the type of this thing. And unfortunately, right now our player is, it's just a game object, right? If we ask for all game objects, we'll get a huge list. But one thing that we can do is we can ask for it by name, or we can ask for it by tag. If you look here, we have a lot of different tags we can choose. Let's look for it by name. So we can say player equals find object. Actually, we have to use a function on game object. The game object class has some static functions, which means they're available without creating an instance of that. And we can say find game object dot find and then give it a name, and that'll return us an object with that name. So let's try this out. So if we say find and put in a name, I've named that player, and then let's uncomment that right there. So this should, if it works, it's going to go into this scene and it's going to find an object with the name of player and store it in our player variable here. And then here we're going to set active to false. Let's see if this works. So in theory, our player should just disappear, and it does. And you can see that, let's see, maybe we could just do a debug over here. Debug.log, and let's have it give us the name of that player. And it's just going to say player because that's what its name is, but we'll see. At least we'll be sure that that didn't work. Why didn't that work? Because I didn't save it, maybe? Could be. Yeah, there we go. So it got a reference to it. I'm not sure why it printed it 3 times, but it did. That's fine. Let's see. So what else can we do? Well, we can also try to find it by its tag. So right now we have a tag on this guy, and you'll find that right up here. There's always this little set of tags. And there's a few that Unity gives us, and we can add our own. Let's try to find it by its tag. So again, this is a function that's on GameObject. Find GameObject with tag. And notice there's 2 of these here. There's GameObjects with tag, which returns an array of GameObjects. And there's a find GameObject with tag, which returns a single one. If you know there's only one in the scene, you can use find object with tag. If you aren't sure, you might only, what this will do is find the very first one that it comes across, which may or may not be the behavior that you want. If you know there are multiples, you probably want to use the find game objects with tag, and we'll try that in just a second. So we'll find game object with tag, and that wants a string that's a tag, and in our case the string is just player. So if we save this, go back to Unity, and press play over here, there we go. We found access to it, and we turned it off. Okay, that's fine. Bear in mind, by the way, this is only going to, if I'm not mistaken, will only return objects that are actually enabled. So if you have objects that are not enabled in your scene, I don't think this will do it. Well, I think there may be another way that you have to do that. But to be honest, I've never tried it, so I'd have to look it up and see. Now, I mentioned that we could find multiple objects with a tag. So what if we did a... Let's say we were going to have some enemies in our game. So if we want to get more than one of these guys, we'll need to put them into an array. So let's do that. Let's make an array called enemies. And down here, so we learned about arrays a little bit in the last couple of episodes. We're going to use find game objects with tag to find all objects in the scene tagged enemy. Right now we don't have any though, so we've just got this guy who's called enemy, but he's untagged. So let's look at how to add a tag. Just pull down the tag pull down and click on add tag, and here we have a little list that we can add to, and we can just type in enemy. I mean, you could put shortbread or whatever you want in there, but for now we'll just put enemy because that seems to be what we want. So we've got one enemy in the scene, and let's go. I'm going to save this, go back over here. Let's do something with our enemy. What could we do with our enemy? Well, we're getting an array, so why don't we do a for next loop and iterate over the array. So for I equals 0 to I is less than, we want to do it for the length of the enemy's array. So enemies dot length, capital L by the way. For some reason, I always think this ought to be a lowercase l, but it's really a capital L, which is why code completion is your friend. Let's just set our enemy at this index to inactive. So enemies, and we'll give it an index of I, because we're going to be counting through these, and we're going to set active to false. Now, there's only one enemy in our array. Let's just reassure ourselves of that. Let's do debug.log enemies.length to string, I guess. I'm not ever sure whether you have to do that or not. Sometimes it seems to work, sometimes it doesn't, but let's just do it to be sure. Save it, come back over here. Now what we should get is in our debug log, we got a warning here. What is this? Warning references.enemies is never assigned. Now, really? Yeah, no, they're right. We never assigned it. Let's see, we still got to get a hold of these enemies. So enemies is equal to our, we're going to use game object, And again, this is calling the static method that's attached to game object, not an actual game object of any sort. We're going to say find objects with tag, and we're going to use enemies. Okay, so in theory, why isn't that working? What have I done wrong here? Enemies, we don't need that. I don't know why. Yeah, we don't need the little bracket there. We just need to say enemies equals that. Sorry about that. Come back over here. This little warning should go away, and we should be able to run it. So we're going to grab our list of enemies, and it doesn't work. The tag enemies is not defined. Did I not save it? Yeah, I didn't save it. No, I misspelled it. Let's edit this. Actually, we may have to remove it. We can just hit minus there to remove that. Should be fine. There should be remove tags, no problem. Yeah, there we go. Now it's properly tagged as enemies. All right, we shouldn't get that error again. And what should happen is both of our guys should disappear. And every update, we're printing 1, which is the length of that array. Goodness gracious, well, I'm showing you guys how to make some errors at least. All right, so let's try this. What if we had multiple enemies in the scene? Let's go see. If we just duplicate this guy a few times, there's 5 of them. And we press play. Yeah, we didn't have to recompile or anything. It removed them all from the scene, and it's printing 5 every update. Probably don't like to spam the debug log like that, but that's what it's doing. It's printing that there are 5 enemies. So it's finding every one of these enemies and putting them into our game object array of enemies because of their tag. It's finding them all, and then we're running through all of them and setting them to false. Now, the reason I'm not doing anything more interesting with these is because we're going to look at next episode. I think we're going to look at how to get hold of the various components on a game object and set those different ways. Okay, let's see. Do we have anything else to talk about? We've talked about, what we haven't talked about is finding a game object of type, finding an object of type. So let's do that real quick. And I think we've done this maybe in a previous episode, but let's do it again. Here's what we'll do. So I've just taken everything out of here. And in fact, I'll get rid of this too. We don't need this anymore. And what we're going to do is on our player script, let's put a little function. Let's call it void move forward. Okay. And I'm going to make this public so that it is available outside the class. So here's void move forward. We're going to go ahead and take a shortcut here. I'm going to say transform, which is the transform of the object that this player script, this player object, right? Because this is a C# object that's attached to a game object. Transform will just get the transform that any component is attached to. So we're going to say transform.translate, which simply moves an object along a vector. And we have the option to just give it a float for X, Y, and Z. So let's give it 0, 0, and let's just say 1. Okay. So in theory, if we call this from somewhere, it's going to translate the thing that this is attached to forward 1 along the Z vector. So there's that. Now, how could we get access to this guy over here? Well, we could certainly say that we want a public player, which is again a class that we've defined in this other script, a public player called player. Notice I used a lowercase p there. And if we save this and go back to our setup over here, we can look on managers and we'll see that we're wanting something of type player. Okay, so we could certainly grab our player and drag it over here, and it'll grab the access to that. If we press start, in theory, our player, well, no, actually didn't do anything. They just got access to it. So let's say player.move forward. We'll just call that function that we defined over there to translate it forward. And if we come here and press play, there goes our guy zipping off into the sunset. So that's one way to get it. We already seen how to do that, but let's try a different way. Let's make this private. Oops. Let's make this private. So right now it'll no longer appear in the inspector, and we have to get access to this another way. Well, that's where find object of type comes in. So player equals find object of type, and we use these little greater than, less than brackets, and we tell it what type inside of here. And the type is player, our user-defined type that we created over here, this class that we made. So we're telling it type player, and then this is the function, so we have to use the little bracket or little parentheses there. So now, in theory, we're going to look through our scene and we're going to find everything that has a player script, a player class attached to it. And then we're going to take the very first one, put it in here. There is also a find objects of type player. In this case, there's only one, so that's what we're doing with it. And we're going to tell it to move forward. So if we save this and we go back to Unity and press play, we should get basically the same functionality that we had last time. That did it to an enemy. Why did it do it to an enemy? Because an enemy has a player script on it, which it shouldn't have. My mistake there. And it happened to grab one of those enemies. So let's just do this. And now our player is the first thing it finds. So that's what happens when you have multiple things with a type on there. You can't be sure which one you're going to get back. Even though I wanted this player, these other things happen to have that player script on it. I didn't even notice or remember, probably because I duplicated the player. But it found one of those first instead of our player here, which is the thing we really wanted. So you have to be careful of these finding stuff in code. If you use find object of type, make sure there's only going to be one of them. Otherwise, you'll want to get it. Let's say we had a bunch of enemies in the screen that had an enemy script on them. We would do it the same way. Enemy, is there a public class enemy? And I'm not entirely sure what that is. Let's call it rhinos, since I know there's nothing called rhino. So we're looking, we've got here an array of rhinos called rhinos, and down here, and it's showing up red because we don't actually have that defined, and we would say rhinos is equal to find objects of type, objects, plural of type, rhino, oops, okay, it doesn't like it because it doesn't exist. I do not want you to autocomplete that, please, just put that on the end of it. Oh, and actually it has the wrong kind of bracket. Anyway, this is absolutely going to make MonoDevelop nuts because it's not going to like the fact that I don't have this defined yet. But right now, we would go out into the scene, find all basically scripts, our user created class of Rhino, and put them into this Rhinos variable. And then we could iterate through this just like we did with the actual array of game object enemies that we had. So if we wanted to access number one, we would say rhinos. That would be our first element of the array. So rhinos 0, and we could call, move forward or take damage or whatever functions we had defined about rhinos. And so that's the way you can get access to objects. There's probably a couple other methods I didn't talk about, but we'll talk about those in the future. And next episode, we are going to talk about how to get components. So once we've got a player, how do we get hold of its capsule collider? How do we get hold of its mesh renderer and then its material? So we'll look at that next time around, and I hope you guys will join me for it. Please let me know if you have any comments or questions. I'll see you next time. Bye.